penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bervisi guru AYU, mencapai misi yang satu, bervisi kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Sirih berlipat, sirih pinang, sirih berasal dari Pulau Mutiara. Selamat datang, awal inilah pembuka bicara. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam Sejahtera. Selamat datang ke kelas tuisyen online percuma bagi subjek Fizik SPM, dibawakan khas untuk anda secara langsung oleh Akademi Youtuber Malaysia, Kelab Guru Malaysia dan IDD Malaysia. Bermula percuma, selamanya percuma. Apa khabar anak-anak pelajar yang cikgu kasihi di mana jua anda berada? Cikgu doakan anda sentiasa sihat dan bahagia di samping keluarga tercinta. Kepada guru-guru yang turut menyaksikan siaran langsung ini, terima kasih di atas sokongan anda kepada Cikgu Hasnitah, khususnya kepada tuisyen percuma di Akademi Youtuber ini. Baiklah, sebelum kita mulakan kelas pada malam ini, ayuh kita mulakan dengan Ummul Kitab, Al-Fatihah dan bacaan doa belajar. Bagi yang bukan beragama Islam, anda bolehlah bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Amin, amin, amin ya rabbal alamin. InsyaAllah mudah-mudahan kelas kita pada malam ini dilimpahi rahmat dan berkat dari Allah Subhanahu Wa Taala dan membantulah anak-anak pelajar dalam persediaan untuk peperiksaan pertengah tahun yang akan datang ini minggu hadapan insyaAllah. Jadi tanpa membuang masa lagi, ayo kita mulakan kelas pada malam ini. Let us continue with our lesson tonight. So I will bring you topic 2.6, force. This is the 6th content standard in chapter 2. And students, if you look at the pin messages, I have pinned for you the PDF copy for this lesson. So you can download and print them out just for free. Anda boleh cetak keluar bahan untuk naskah murid dalam bentuk PDF secara percuma sahaja. Mudah-mudahan membantu anda dalam memahami tajuk ini dengan lebih baik. Okey, jadi jom kalau semua sudah bersedia, if you are good and ready to go student, let us begin with our lesson. But before that, can you give me some response? If you can hear me clearly, can you please type 1 in the live chat? Kalau anda boleh dengar cikgu dengan jelas, boleh type 1 tak pada live chat? Okay, please type 1 if you can hear me clearly. Okay, thank you for your response. So what do we have in 2.6? Force. Before that, I would like to introduce to you, this is our apps, Akademi Youtuber apps. You can download from your Android, from Google Play Store. This is an app containing PDPC videos from preschool until pre-university level. So far until today, we have 26,000 PDPC video produced by volunteers from Akademi Youtuber, teachers involved with Akademi Youtuber from all over Malaysia. Kita ada Ciaing di sana. Salam sejahtera Ciaing. Semoga Ciaing sihat selalu. Okay, thank you for always supporting me. Jadi yang belum muat turun apps Akademi Youtuber, jangan lupa muat turun di Android anda sekarang. Ada banyak video di sana mengikut mata pelajaran yang anda boleh gunakan sebagai bahan tambahan ulang kajian. Alhamdulillah, cikgu sihat Ciaing. Alright, so student, this is the learning standard for 2.6. There are 2 learning standard only, very simple. So the first one, each and every one of you must know how to define force, okay, as a rate of change of momentum. We learn momentum 4 in 2 in 5, all right? And next is to solve problem involving force F equal to MA. All right, okay. So can you see what is, I believe I've learned it in school, right? Okay, anyone can tell me what is, apa itu daya? Apa maksud daya? What is meant by this? All right, okay. So generally, any pushing or pulling action can be described as force. Okay, what is force? Pulling or pulling action. Pull or push. Pushing an object, you are pulling an object, so you apply of that object. All right. Okay, so in general, force is action of pushing or pulling. Okay, let us take a look at a few examples of force in our daily life. Okay, so in the first GIF is pushing a vehicle. So they apply a force to that vehicle. A man is cyclist, apply force. So he moved forward. Okay, and a ball, stop a ball from moving, apply a force to the ball, make it stop. Okay, and here a man is pushing a box in this direction, so he apply a force to that box. And the last one, a boy kicking a ball, apply a force to that ball. So this is example of daily situation involving force, pushing or pulling action. All right. And what are types of forces that we have? Apa contoh daya yang kita ada? So we have magnetic force, applied force, buoyant force, which causes an object to float in the air, tension, a force applied to a rope or a string, and then we have drag force, also known as resistance to a spring. All right, so this is a few example of types of forces. All right, students. Okay, next. So in physics, okay, what is the definition for force? So force is defined as a rate of change of momentum, right? And this is the equation for force you will learn in this topic. F equal to ma, where F represents the force applied to the object, m is the mass of the object, and a is the acceleration of the object. So student, when you apply a force to an object, the direction of acceleration equal to the direction of the applied force. All right, and force is a derived quantity. It is a combination of mass and application through multiplication, and also it is a vector quantity. It has both magnitude and direction. Ia tak ada kelas hari Jumaat ya, sebab Cikgu Izyan yang sepatutnya present, dia tak dapat kerana ada sedikit kekangan lah. Jadi insyaAllah Jumaat depan kita akan bersiaran bersama teacher Slinda, Nordin. Alright. Okay, seterusnya, next student. Okay, so if you look at this question, how does, look at this animation, there is a box moving in straight line in 3 different situations represented by the motion graph there. Okay, if you look at the first graph, it is a graph of acceleration against time. Understand that the object moving with uniform acceleration. All right, and the second graph represent graph of velocity against time. So a uniform acceleration means the velocity increases uniformly. Okay, so the velocity of the box increases uniformly. And this is the graph of displacement against time. So it is a curved graph for displacement. So the gradient show you increasing velocity. So this is 3 example of graph which explain the motion of an object moving in uniform acceleration or increasing velocity. Alright, okay. So this is one activity in your textbook which you can conduct in school to understand force and the relationship between force, mass and acceleration. Okay, we have two activities here. The first activity is to investigate the mass is constant. Alright. Okay. Waalaikumsalam Cikgu Syukur. Terima kasih join kelas pada malam ini. Okay. Kita ulang kaji tajuk force malam ini. Alright. Okay. So for the first activity, our MV is, can you tell me what is our MV here? So our MV is force. Yeah, we change the force and we maintain the mass. So the responding variable is acceleration. And this is the setup for this experiment. Alright, a trolley is attached to a ticker timer in an inclined plane. Alright, and you can read the instruction from number 1 to number 5. Okay, let's say this is the table of result, okay, obtained from this activity. So we have a table of force there using one elastic spring, and then we change to 2 strings and we change to 3 strings. So the number of string represent the magnitude of force applied to the trolley. So this is the initial velocity, final velocity, the time and the acceleration of the trolley. So if you remember, we have conduct experiment or activity on ticker timer in the previous topic. So I hope you understand how to analyze this result for the ticker timer shows here. Alright. Okay, so let's say this is the ticker timer obtained from this activity. So how to find the initial velocity for one elastic string. Alright. So if you look at the first step, the length is 2.5 cm. Remember, the length represents the displacement. Alright, and each tape contain 10 ticks. So this is the time for each tape. 10 ticks multiply 0.02 second for each. So this is the initial velocity, 12.5 centimeter per second. So we record in this table. And for final velocity, you have to look at the final tape number 6. Okay, if shown here. So the length of this tape is 5 centimeter, represent the displacement, and this is the time, 10 ticks inside, multiply the time for one tick, 0.02 seconds. So it will give you 25 centimeter per second. So you can see the velocity is increasing, showing that the trolley is accelerating. All right. Okay. And for the time interval, you have to find the time interval in order to determine the acceleration, student. So how to find the time interval? Time interval is the changes from the initial velocity to the final velocity. So this is the formula. N minus 1. N is number of tape. So we have 6 tape there, minus 1. Multiply time for each tape. So each tape is 0.2 second. Alright. So it gave us 1 second. So from here, we calculate the acceleration. Acceleration is a rate of change of velocity. So final velocity 25 minus initial velocity 12.5, divide the time interval 1. So it will give you 12.5 centimeter per second. So we fill up our table. And then we use the same method to determine all this quantity for 2 and 3 elastic strings. Okay, and let's say this is the reading determined. Okay, this is example of reading determined from this activity. So how we analyze the data from the table? So you have to plot a graph of acceleration against force. This is our RV. This is our MV. All right. The unit is Newton. Okay, or unit. Here we are not using Newton because it represents by the number of spring. All right. Okay, then. Alright, so this is the first when using one elastic string, when using two string, and when using three string. Alright, and we join all these three dots, so we have a straight line from the origin. Okay, we have Jimmy also here. Hi Jimmy, how do you do? How's your SPM result, Jimmy? Okay, I'm sure it is an excellent one. All right, okay, students. So from here, what can we conclude? Okay, so from this graph, it tells us acceleration is directly proportional to the force when the mass is constant. All right, so this is the relationship between A and F. It is directly proportional. All right, okay, next. Okay, so I hope you're clear with the first activity, the relationship between force and acceleration when the mass is constant. They are, yes, directly proportional. We also have Tarvin here. Tarvin, anak lelaki Saravana. May I know which school you are from, Tarvin? Are you friend with Jimmy? Alright, next. Okay, for the second activity, now we keep constant the force. The force is keep constant and we investigate the relationship between mass and acceleration. So now our variable CV is force. Okay, our MV is the mass. We change the mass by using different number of trolleys. All right, and our responding variable again is the acceleration. All right, yes. And you can read the instruction from number 1 to number 4. Okay, again, for those who are just joining us, don't forget to get your PDF copy. I have pinned them in the live chat and also found in video description below. You can click on the link now or later and keep them, print them out all for free. Percuma saja, tak perlu bayar apa-apa. Alright, okay, next student. From SMK Kampung Raja. Okay, thank you for response. Alright. Next, students. Okay, again, this is the chart. Okay, we determine from activity B and this is the table of result. Okay, again, how we calculate the initial velocity by referring to the first tape. Okay, the displacement, the time, so it is 5 centimeter per second. The final velocity, look at the 6 tape length, 6.0 centimeter. This is the time, so it gives you 30 centimeter per second. All right, then we find the interval, time interval, and the acceleration. All right, okay, I hope you're clear how to determine all this value because you have learned this before in 2.1. Okay, 2.2. All right. So we fill up this table, U5, V30, T1, and acceleration 25. And let's say this is the reading obtained for 2 trolleys and 3 trolleys. All right. Okay. So how to analyze the graph when you are given this data? Okay, so in physics, it is very important for you to do data analysis. Then only from that, you can understand the relationship between the parameters asked in the question. So we plot a graph of A against mass here, the unit. All right, okay. So if you look at this graph, okay, now it is a curved graph with negative gradient. So remember we learned in 1.2 scientific investigation. From this graph, can you tell me, Tavin, what is the relationship between A and M here? All right, or Jimmy also can respond, or anyone else there following us, can you share your answer? What is the relationship between A and M according to this graph? All right. Okay, don't be shy. Okay, you can try to share your answer before I show mine. Alright. Okay, siapa nak kongsi jawapan boleh type pada live chat. Apa hubungan antara pecutan dan jisim? What is the relationship between acceleration and mass according to this graph? Yes. Okay. So we give some time to the students to write their answer. Ciaying pun nak cuba jawab apa hubungan antara A dengan M di sini. A is pecutan, M is jisim. A itu pecutan, M adalah jisim, mass. Acceleration and mass. Alright. Yeah, very good. The relationship is inversely proportional. So from the graph, acceleration is inversely proportional to mass when the force is constant. So this is another graph you can plot for inversely proportional. A and here is reciprocal of M. Alright. When you draw this graph, it is a graph of acceleration against the reciprocal of M. So it will be a straight line graph showing that A is inversely proportional to mass. Alright. So are you clear, student, with activity A and activity B? How we determine the relationship between F, M and A by conducting two activity. Yeah, very good, Jimmy. Thank you. Inversely proportional. Yes. Alright. So what conclusion we can make from these two activities, students? Okay, so it shows that acceleration of an object is depend on the applied force and the mass of the object. So there are two factors affect acceleration. The first factor is force. The second factor is the mass of the object. Ya, berkadar songsang in bahasa Melayu. Yes. Alright. Okay, and this is the relationship between A and F when mass is constant, where A is directly proportional to F. Acceleration directly proportional to F. And for acceleration and mass, it is inversely proportional. So when you combine these two, what will we have? Okay, we have this F, okay, this is the relationship F directly proportional to M and A. And if you write in terms of mathematics, alright, so A can be determined as V minus U divided T. Okay, and we multiply M to these two, so MV minus MU divided. So this is what we say the rate of change of momentum. Force is rate of change of momentum. And in mathematical expression, F equal to kma, where k is a constant and this is 1. Finally, we determine F equal ma. And this is known as Newton's second law. 1 Newton means 1 Newton is the force produces an acceleration of 1 meter per second squared when applied on a mass of 1 kg. Okay. In a simple way, when you apply a force of 1 Newton on 1 kilogram of mass, and the unit for Newton is kilogram meter per second squared. Kilogram is coming from the mass, meter per second squared coming from the acceleration, or normally we write for Newton, capital N, Newton. Alright, okay, so this is the SI unit for force, kilogram meter per second, or generally we write them in Newton. Alright, okay. Okay, so that is the first part a while. We go to the next of exercises and question on force. So don't go away. Okay, student and teachers, welcome back. So I notice we have a few new students with us tonight. We have Yuan Liu, hi. You also have Chan Mei Yi here with us, and ZY12, also Tan Kai Xuan. Who else? We have Min Yong, okay, and also we have Tiva, Tiva Tashni, Kavya as well. I guess you are from the same school, SMK Kampung Raja. Correct me if I'm wrong. And this is Zishuan. Okay. Are you Jimmy's junior? Seems like you know him. Which class are you? Alright. Okay, students. So let us continue with our discussion. So what will be the next? Mass and acceleration from the equations of Newton's second law, F equal to ma. Okay, and students, now let us take a look at what is the effect of unbalanced forces acting on an object. Can you guess, or can you share to us in your understanding what will be the effect of unbalanced forces acting on an object? Okay, I'm waiting for your answer. Okay, we also have Hui Xuan here. I'm sorry if I didn't pronounce them correctly. Shum or Sham? Shum Hui Xuan. Alright. Shum Hui Xuan. Alright. Okay, Yukesh Saravanan also here. Thank you very much for joining Cikgu Hasnitah this evening. Alright. Okay, what is the first effect, student? Yukesh. Yes. Are you also from SMK Kampung Raja, Yukesh? Okay, the first effect, student, unbalanced forces will cause a stationary object to move, or also it will stop a moving object. All right. Second, unbalanced force will increase velocity of an object, or the object will accelerate. Okay. And number three, unbalanced forces also causes the velocity of the object to decrease, or we say the object decelerates. All right. And number four, unbalanced force can change the direction of motion of an object. And last but not least, it can change. Okay. It can change the shape of object. All right. Okay. You will learn more detail on unbalanced forces later in Form 5. Alright? Okay. What about balanced forces? What are two if the? Siapa lagi di sini? Yamuna Shri. Alright. Okay. Thank you for being here. Okay, next student. Okay, so for Form 5, we focus on balanced forces acting on an object. Okay, students. Okay. The first one, if you look at this GIF or this diagram with us, what is the effect of balanced forces on an object? Yeah, very good. The first one, when the forces acting on an object is balanced, it causes the object to remain at rest. The object will remain at rest, or it keep stationary. Okay, mean the force to the right equal to the force to the left. Let's say 10 Newton to the right and also 10 Newton to the left. Okay, so the object will remain at rest. Or what else might happen if the forces are balanced? Yeah, very good. The object will move with uniform velocity. Or for the unbalanced forces, yes, the object will accelerate, the object change in shape. Okay, and when the forces are balanced, these are the two possibilities might happen to the object. Okay, remain at rest or stationary. Second, move with uniform velocity. All right, so you have to keep in mind these two situations. Object keep at rest or remain at rest. Second, moving with uniform velocity. All right. Okay, next. Now let us look at the application of force in our daily life. Okay, can you tell me in which, imagine if there is no gravitational force around us, what will happen to you? What will happen to Cikgu Hasnitah? Alright, okay. Yeah, things will float in the air. Okay, if there is no gravitational force, no gravity acting. Next. What about this? Imagine frictional force does not exist. See what happened to the cyclist. Based on frictional force, disaster will happen, right? So when there is no frictional force, we will sleep while walking, whereas vehicle become non-stoppable. So it can cause a catastrophe. All right. Okay. Next, student. How about this? There is no magnetic force. What do you think might happen? Can you find direction using compass? No magnetic force exist when this situation, especially during navigation. Okay, so this tells us how important forces is in our daily life. All right. Okay. So now this is what the advantages or the benefits for force. For example, electric force, okay, help us to comfort our life. You can do all the ironing, cooking, and so on when electric force is exist. Okay, now the first part is done. All right. So now let us take a look at the second part. To solve problem involving force. So I guess you can be ready with your calculator. All right. And we solve this together. Okay. This is similar to formative practice 2.6 in your workbook. Okay. So if you have a textbook, you can open them. Look at formative practice 2.6, or for those who have download and print out this module, you can straight away do them in your own. You can grab a sketch paper and just do the calculation there. All right. Okay. So now question number 1, we have a force acting on an object with a mass of 5 kg. All right. Okay. Now the first question, the body or the object accelerate uniformly from 2 meter per second to 8 meter per second in 2 seconds. So find the value of F, student. So the first question, they give us M, the mass. What is this 2ms? Yes, very good. This is the initial velocity, and 8 meter per second is the final velocity. Yes. T is 2 seconds. So find F. Okay, so remember what is the formula for force just now? F equal, yeah, mv minus mu divide T. Okay, so this is all the given information for you to find F. Okay. So F equal to ma. This is Newton's second law of motion. And A can be written in terms of V minus U divide T. Okay. Okay, please find the answer. I want to see who's the fastest in solving question. Kai Ro Heng. Okay, welcome to our class. Now we are discussing the first exercises, similar to formative practice 2.1. Okay, are you done? Who's done? Can you share your answer? What is the value for F here? Okay, this kind of question can be come out in paper 1. So how to solve them? Easily. Yes, very good. So the answer is 15 Newton. Okay, did you get 15 Newton? Who get 15 Newton? Type 2. Who get 15 Newton? Type 2. Okay, very good. Kavya. Okay, 15. Don't forget the units. Okay, remember in physics, any solution you must write together with the unit 15 Newton. Okay, good. Okay, thank you for your effort. Yeah. Okay, next. Okay, what about B? Now, if the value of F is 10 Newton, now they give you the value for F, 10 Newton. So now find the displacement. Calculate the displacement of the object 5 seconds after the body starts to move from rest. Okay, how to solve? Question B. Which equation you can apply here? So we are looking for displacement. Displacement is S. Okay, and the time is T. F is 10. It say after the body start to move from rest. So move from rest, which means initial velocity is 0. So for this question, it is actually a combination of linear equation and force. Yes, very good. So how to find S, student? Yeah, again, this is the information you are given. Okay, we are looking for S there, displacement. Alright. So how to find displacement? Find acceleration by using F equal ma, where F is 10, m is 5, and acceleration we are looking for. Yes, Jimmy, very good answer for 1A, 15 Newton. Okay, so acceleration is 2 meter per second. Okay, now we can find the displacement by using linear motion equation. So we can use this equation. Okay, S equal UT plus half AT. So remember, you have 4 linear equation you can apply. So we choose this without V, the equation without V. So S equal UT plus half AT squared. So now you do the substitution. Okay, SU is 0. It started from rest. So acceleration calculated earlier. So acceleration, the time is 5 seconds. So our displacement is 25 meter. Okay, the object move 25 meter from the starting point when apply a force of 10 Newton to it. Alright, okay, so I hope you are clear with the solution for question number 1A and 1B. Okay, now let's move to question number 2. Alright, okay, now we have a force 60 Newton acting on a stationary object for 5 seconds and causes the object to reach velocity of 30 meter per second. So first you have to find the mass, and second, find the displacement. Okay, so now find mass. You are given F, 60. You are given time, 5 seconds. You are given 30 meter per second. This is the final velocity. Initial velocity, how to know? You see the word stationary there. It means initial velocity is 0. Yes, very good. So this is all the given information from this statement. F60, T5, we are looking for M. So how to combine all this to find M? Very good. F equal MV minus MU divide T. Alright, yes. So you just do the substitution. F60, we are looking for M, V is the TU0, and time 5 seconds. Okay, solve this. Tell me what is the mass. Okay, so you have to be very careful here when doing the operation involving multiplication and division. Okay, tell me what is M in question 2A. What is the mass of the object? Okay, while you are doing the calculating, don't forget to give thumbs up to this class. Okay, thank you very much for your support. Okay, are you done, students? Chan Mei Yi, are you done? Okay, who else we have? Kavya. What about Rohang? Are you done? Yukesh? Yu Cheng? Who else? Mei Yi, Tiva. What about you? Okay, 10. Mei Yi say 10. 10 kg. Okay, let us check. Yes, very good. 10 kg. 10 kilogram is the mass. Easy, right? Okay, Yamuna also say 10 kg. Okay, now move to question B. Find the displacement. Okay. Similar to 1B, find the displacement. Displacement is S. So we have to deal with linear motion equation. Okay, Chia Ying also 10 kg. Very good, Chia Ying. Bagus. Okay, next. Find the displacement. Okay. Okay, I give you a clue. Okay, this is all the given information. U is 0, started from stationary, final velocity is 30 meter per second, time is 5, acceleration is 6. Okay, calculated here. Okay. So we have find S. Okay, you know how to find acceleration 6, right? F equal MA. Okay, F is 60, M is 10, so acceleration is 6. Okay. So we are using this equation. S equal UT plus half AT squared. So answer 75 meter. Or you have another option. You can also use this equation. V squared equal U squared plus 2AS. Okay. So we substitute. V is 30 meter per second. Initial velocity 0 to acceleration is 6. And we can find the displacement. So they give you the same answer, 75 meter. Okay. If you have any question, you can type. Any part you are not clear with, you can ask in the live chat. Please don't be shy. I will be very pleased to assist you. Okay. So can you follow? Solution for question 2A and 2B, yeah, Chia Ying, 75 meter. Okay. Who else get 75 meter for the displacement? You can type 1 in the live chat. Okay. So I think we can move to the next question. Okay, very good. Okay, now this one, very, very simple calculation. To familiar yourself with Newton's second law of and force of forces acting on them. Okay, very good, Kavya. Okay, now move to the first question. Okay, find the acceleration in each situation. Okay. Okay, 1A, the mass of the block is 2 kg. There is single force acting 8 Newton. So ini tak payah pakai calculator. Calculator is not need here, not necessary. Okay, you can tunggak saja. Alright. So what is the answer for first? Find the acceleration. Okay, so using F equal to ma. Yeah, very good. Our acceleration is 4 meter. F is 8, m is 2. So acceleration 4 meter per second square. Very good, Mei. Okay, don't forget the unit, meter per second square. Okay, what about B? There are two forces acting on a block with a mass of 5 kg there. 6 Newton acting to the right, 14 Newton also acting to the right. Please be alert with the direction of force. Okay, so how to find acceleration here? So this is the net force acting on the object, 20 Newton. So 20 equal to 5A, which means acceleration also, yeah, very good. Also 4 meter per second. Okay. Okay, next, student. Next, question C. In question C, also we have two forces acting, but they are now in opposite direction. 2 Newton is to the left, 18 Newton to the right, acting on 10 kg block. Okay. Okay, Jimmy is responding to my previous question. Okay. Okay. So what is answer for C? Net force. So since the force is opposite direction, so we put negative there, minus 18 minus 2. Okay. So 16 is the net force acting to this block. So acceleration is 1.6. Okay, Joris here. Very good, Joris. Thank you for your efforts. Okay, next, last one. Okay, last one, I have to zoom it for you because the third arrow is not very clear there. So if you notice in question D, there are three forces acting on the block of 12 kg here. First, we have 10 Newton acting to the right. And then here we have 5 Newton to the left. Another 5 Newton to the left. Okay, 10 to the right, 10 to the left. All right, so what is the answer? What is the acceleration here? Okay, so from here we understand acceleration is 0. So what do you think happened to this object? So from our solution, we understand object A accelerate to the right, okay, at 4 meter per second squared. B accelerate to the right with 4 meter per second squared. What about C? C also accelerate to the right with 1.6 meter per second squared. Okay, what about D? What happened to D? Student, what happened to the block in D when the acceleration is 0? Can you tell me what happened to this block? There are two possibilities can happen to B. Okay, yes, the first one, the object is remain rest. Second possibility, yes, the object move with uniform velocity. The object move with uniform velocity. Yeah, very good. Okay. Okay, good. Okay, now let us take a look at question 2. Okay, this is example of question in paper 2, question 5 and question 6 in section A. Alright, okay. So first we have diagram A and B. Okay, can you tell me what is the similarity or what is the difference between these two diagrams? Look at the similarity first. The similarity, yeah, the trolley has the same mass of M. Okay, the trolley has the same mass of M. The difference is this one is pushed by one person, this by person mass. Here the okay, the difference is force, is acceleration. So at A, the object accelerate with A. In B, object accelerate at A. Okay, then what is our question? Okay, our question. What happened to the object? Okay, what happened to the object when a force F acting on mass M? Okay, they ask you to refer to diagram A. So we see object accelerate, okay, in the direction of the force applied. Okay, yes, very good, Jimmy. Okay, next. Next question. Student, what happened if the force acting on the same mass now double as shown in diagram B? So B, we double the forces. So what happened to the acceleration? Yeah, you can see when we double the force, the acceleration will also double or increases. Okay, when mass is constant, when as the mass is constant, when F increases, acceleration also increases. Yeah, very good. So from here, what is the relationship between F and A? Similar to our previous slide. Okay, very good. So yeah, A is directly proportional to F. Acceleration is directly proportional to the force F. Okay. Okay, next. Okay, now we have A and C. Okay, A and C. Now, what is the similarity between A and C? Yes, we apply the same amount of force. One man pushing. Okay, what is the difference? Yeah, now the difference is in the mass of the trolley. This one box, 1M. This one, 2M. Okay, so the question here, what happened if the same force acting on the mass of 2M as shown in diagram C? So you can see the acceleration decreased by half. Acceleration decreases. All right? Okay. And then next, from here state the relationship between mass. They are inversely proportional. When the mass increases, the acceleration decreases. Inversely proportional. Okay? Okay, before we go to later I will share to you the link for e-sijil at the end of this session. So nanti anda jangan terus keluar ya. Anda klik dulu pada link, dapatkan sijil, isi maklumat. Sijil ekspres akan dihantar kepada anda dalam tempoh yang sangat singkat, in a very short, less session 3. Okay, we have an object with maths. Okay, I hope you're still doing well there because now we are doing question in solving problem involving forces. Okay, object 2 kg mass. Pull on the floor by force, constant velocity. Okay, constant velocity means what? Yeah, acceleration. Zero mean the thrust force and the frictional force is the same. Alright, so first, what is frictional force between the object and the floor? Okay, actually this one no need calculation. Okay, we understand the frictional force also? Yeah, 5 Newton. Okay, so frictional force equal to the applied force 5 Newton. Answer 5 Newton. Yeah. And B, question B. Now you have to find the acceleration of the object if now it is pulled with 17 Newton force. Okay, so how to draw the situation is 5 Newton between the box and the floor, and now we increase the pulling force to 17 Newton. So now we have a net force of 12. 17 minus 5 Newton. So net force of 12 Newton acting in the direction shown by the arrow. So by this, it is now accelerate at 6 meter second. Equator is 5 Newton. Answer for A. Alright, okay. Okay, so when we increase the pulling force from 5 Newton to 17 Newton, now the object accelerate at 6 meter per second squared. Okay, good. Okay, next. Question 4. Okay, question 4. Alright. Okay, question 4. Altogether, we have 5 questions. So this is the last 2 questions. Question 4. Where the pin messages? Okay. Okay, now question 4. Now we have a bus. Mass 2000 kg. Travel with uniform velocity 40 meter per second at the distance of 2,500 meter before it comes to rest. Comes to rest means, yes, the final velocity is 0. Yes. So now find the average deceleration of the bus. Okay, what is the average deceleration? Okay, so this is all the information given. Make sure you are familiar with all this symbol. S represent distance or displacement. U initial velocity 40. V final velocity as it come to rest. Okay, or come to stop. And we are looking for A, okay, the average deceleration. So how to find A? So you can see motion equation. Okay, you can use linear motion equation of V squared equal U squared plus 2AS. Alright, okay, now we do the substitution. V is 0, U 40 square, 2, we are looking for A, acceleration, and this is the displacement, 2,500 meter. Okay, can you solve for me? Find A here. Okay, please make sure you are familiar with your calculator, especially in chapter 2 and chapter 3, because we are dealing with a lot of number, especially in gravitation. Okay, yeah, answer negative 0.32. Why negative? Because the bus decelerate. Okay, it decelerate at 0.32 meter per second square. Okay, yeah, very good. Can find the average force. Find the average force applied by the brake to bring the bus to a standstill. Okay, how much force you have to apply in order to make the bus to come to a stop. Okay. Don't be afraid. As I mentioned, you are dealing with a lot of number. You just have to familiar yourself with exercises. Okay. When you are familiar with exercises, there won't be any difficulties, especially during the exam. So you must practice doing exercises every day. Okay. Okay, next student. Okay, so this is our given information. Mass 2000 kg, acceleration 0.3. F equal ma, the force. So the force is negative 650 Newton, okay, or 650 Newton. Okay. So are you clear with question 4, student? If you are clear or you can follow, you understand the solution for question 4, can you type for me number 4? Okay, type for me number 4. If you are clear with the solution for question 4A and 4B. Okay. Lagi 3 minit. Okay, sekejap lagi Cahaya. Nanti cikgu akan share link sijil. Okay, very good. Okay, we go to the last question for tonight. Okay, the final question. Question number 5. Okay, this is SPM past year question. Okay, I don't remember the exact year, but it used to come out in the previous SPM 1 and 5.2. 5.1, we have 2 cyclists. Okay, both of them are cycling. In diagram 5.1, both of them are cycling. Okay, and they reach the destination in 3 seconds. Okay, and in diagram 5.2, only one person cycling. Okay, and they reach the destination with the same distance later, after 7 seconds. 5 reach in 3 seconds, 5.2 reach in 7 seconds. So you can see the difference here is the number of persons cycling, which represent the force applied. Okay, this one man cycling. So this one 2 men cycling. Okay, and smaller force applied. Okay, first, can you name the force acting between the bicycle and the road? Okay, what is the force acting between the bicycle and the road? Actually, there are 2 answers you can give there. The first one, the first one you can say frictional force between the wheel of the bicycle and the road. Second, it is gravitational force, the weight of the bicycle and the cyclist. Okay, there are 2 answers you can put there. Daya geseran Cahaya, bukan daya gerakan, daya geseran ataupun daya graviti. Alright, okay. Next. Okay, next you are asked to compare. Observe both diagram 5.1 and 5.2. Compare the force cyclist that cause the bicycle to move. So how to compare the force? Okay. So the force, as I mentioned, represent by the number of persons cycling. Here, 2 persons cycle. And 5.2, only 1 person cycle. So what can you say? How you compare the force? Which one bigger? Which one smaller? Or are they equal? Yeah, very good. So we say in 5.1 greater than 5.2. Force in 5.1 greater than that in 5.2. Or you can use this symbol, greater than 5.1 greater than 5.2, or vice versa. 5.2 smaller than or less than 5.1. So this is how we compare the force. Okay, second, compare the time taken to travel the same distance. Now compare the time. Who's longer? Who's shorter? 5.1 just now 3 seconds. 5.2, 7 seconds. So when you compare, use either equal, greater than, or smaller than. Okay, 3 comparison. Either they are equal, greater than, or smaller than. It can be used in all situations. Okay. So time taken, 5.1 shorter or smaller than 5.2. Okay, 5.1 less than 5.2 or vice versa. 5.2 greater than 5.1. Alright, okay. Now based on your answer in B2, compare the acceleration of the bicycle. Okay. Who has higher or larger acceleration, 5.1 or 5.2, student? Compare the acceleration. Who has higher acceleration, 5.1 or 5.2? Definitely. Yes, definitely 5.1. 5.1 has a greater acceleration compared to 5.2. Or you can use mathematical symbol, 5.1 greater than 5.2 or vice versa. 5.2 less than 5.1. Okay. Okay, finally, relate. Number 4. Not final yet. Number 4. Relate the force applied by the cyclist to the acceleration. So, how does force relate to acceleration here? Yeah, very good. So, they are directly proportional. Or you can say when force increases, acceleration increases. Okay. Yes. Okay, now next. Okay. Can you name the physics law involved in 5 force and acceleration? Can you name me the law? We have discussed the law earlier. Yeah, very good, Jimmy. So it is, yes, Newton's second law of motion. Newton's second law of motion. Okay. And D, this is okay, key but. D1, what happened to the acceleration of the bicycle in 5.1 when both cyclists bend their body forward? Okay, what do you think happened when the cyclists bend their body forward? Any changes happen to the acceleration? Definitely yes. So the changes are, yeah, very good. The acceleration of the bicycle will increases. Yeah, acceleration of bicycle increases. Or you just say acceleration increases. Okay, enough. How? Why? Why do you say so? Why acceleration increases when they are both bending their bodies? Okay, very good. Because this will reduce A resistance. Okay, A resistance decreases. A resistance reduce, or the net force is greater. A greater net force acting on the bicycle. So that's why the acceleration decreases. Okay. So last question. Okay, soalan terakhir, calculation. Okay, last question, student. Okay, total mass of the cyclist and the bicycle in 5.1 is 100 kg. Okay. Okay, if they start from rest, achieve velocity 10 in 2 seconds, find the force applied. Okay, this is similar to the previous exercises before. Okay, this is a very straightforward question. They give you all this. Find F. Okay. Yeah, so we are using F equal to MA. This is the mass, 100. Acceleration can be, okay. So by this, the force applied is 500 Newton. 500 Newton. Okay. So I guess that's all with the discussion and exercises, example of question on 2.6 forces. So what do you think about this chapter? So as I promised, this is the link for the e-cert. You can click on them and please fill up your name and your IC number correctly. Then the cert will be generated and sent to you in less than 10 seconds. You can use any account, any email account for this cert. Okay. Thank you very much, Jimmy, and thank you very much, everyone, for joining Cikgu Hasnitah tonight. I hope you are clear with 2.6 join kelas cikgu malam ini. Semoga membantu anda menyiapkan diri untuk peperiksaan nanti. Dan jangan lupa minggu hadapan kita akan teruskan dengan tajuk yang seterusnya, 2.7 Impulse and Impulsive Force will be presented by Mr. P. Kok Hwa. And for Form 5 classes on Friday will be continued by teachers Slinda, Nordin with 2.4 if I'm not mistaken, Pascal, prinsip Pascal, kelas untuk Non-DLP. Jumaat 9.30 malam, dan minggu depan Mr. P akan bersiaran pukul 2 petang kerana malam tu ada perarakan Hari Wesak. Beliau ada perarakan Hari Wesak. Dia akan buat kelas lebih awal. So next Sunday will be continued by Mr. P with 2.7 Impulse and Impulsive Force at 2 p.m. Okay, again, thank you very much. Terima kasih banyak-banyak. Selamat berehat. Okay, have a good sleep, have a good rest, dan selamat maju jaya dalam peperiksaan akan datang. Jadi segala yang baik itu daripada Allah SWT, yang kurang itu daripada kelemahan diri cikgu. Mudah-mudahan kelas pada malam ini membantu anda untuk faham tajuk ini dengan lebih baik. And thank you for supporting me from the beginning until now, and see you again soon. Jumpa lagi dalam kelas yang akan datang. Bye-bye everyone. Assalamualaikum dan jumpa lagi.
Marah semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa.
Akademi Youtuber Malaysia, berpadu bersatu keluarga AYU, memberi ilmu tanpa jamu, siap sedia menyumbang ilmu.
Ilmu diberi juga dikongsi pada semua generasi yang terkini, lahir generasi yang berkualiti, sedia berkhidmat pada pertiwi. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa. www.academyyoutuber.com. Berusaha AYU capai kecemerlangan, berpadu AYU cipta kegemilangan, bersatu AYU bina wadah terbilang, terus berjaya bersama AYU.
Berusaha AYU capai kecemerlangan, berpadu AYU cipta kegemilangan, bersatu AYU bina wadah terbilang, terus berjaya bersama AYU.
Marah semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa.